Hello friends, this is a 2-mark question on DMGT and topic graph theory. The question reads as follows. Let G be a planar graph such that every face is bordered by exactly 3 edges. Then, which of the following can never be the value for x of G, where x of G is the chromatic number of graph G. We say that a graph is a planar graph if it can be drawn on a sheet of paper and none of its edges cross each other. For example, consider the following two graphs. Both of these graphs are planar since none of its edges cross each other. Also, both of these graphs are complete, that is, each vertex in this graph is connected to all other vertices in the graph via a direct edge. In the first graph, we have 3 vertices and the chromatic number for this graph is 3 because we will need at least 3 different colors to color the vertices of this graph such that no two adjacent vertices have the same color. Similarly, we need at least 4 different colors to color the vertices of second graph. So, the chromatic number of the second graph is 4. Both of these graphs also satisfy the constraint specified in the question. That is, every face of this planar graph is bordered by exactly 3 edges. In the first graph, we have only one face which is bordered by 3 edges. Whereas in the second graph, we have 3 faces and each one of is bordered by exactly 3 edges. So, both of these graphs satisfy the given constraints. Now, we know that any planar graph G has a chromatic number less than or equal to 4. And if every face of a graph G is bordered by 3 edges as shown in the above graphs, then the chromatic number for such a graph should be greater than or equal to 3 because each vertex in such a graph will be incident on at least 2 different edges. Since the given graph is planar as well as has every face of a graph bordered by exactly 3 edges, we can say that the chromatic number for such a graph should be 3 or 4 from these two statements. So, out of the given options, option A, that is 2, cannot be the chromatic number for such a graphs. So the correct answer to this question is option A. Thank you.